Okay, so let's go ahead and take a look at this lesson. So average mean value. So we are going to cross out this part for right now. And we're going to cross out the word mean. Because every single time you see the average value, you're going to take 1 over b minus a and find the antiderivative. So I want to find the average value of example 1. 1 over pi minus 0, antiderivative 0 to pi of sine of x dx. And then I could do this by hand, or I can use FNet. So 1 over pi negative cosine of x, 0 to pi. So I get 1 over pi cosine of pi plus, and that should be negative, plus 1 over pi cosine of 0. And so I get 2 over pi. Okay. Average value shown over a graph. So my average value (1 over 4 minus 0), antiderivative from 0 to 4. And I'm looking at all these little regions. So let's see. I can go triangle, rectangle, and to trapezoids. So 1/4, and then 1/2 times 1 times 2, plus 1 times 2, plus 1/2, 2 plus 1 times 1. And then plus 1/2, 1 plus 2 times 1. And so I'll get average value is equal to 3/2. Okay. Average velocity, when I'm given the velocity equation, is average value. So 1 over 3 minus 1, antiderivative from 1 to 3, 3t squared minus 18t plus 24. So then, average value, 1/2 t cubed minus 9t squared plus 24t, take my antiderivative from 1 to 3, and then I plug everything in. I can go average velocity. So average velocity, (1/2) 3 cubed minus 9 times 3 squared plus 24 times 3 minus 1 cubed minus 9 times 1 squared plus 24 times 1. So average velocity is equal to 1. Position is the antiderivative of velocity. Velocity can be the antiderivative of acceleration. Speed is the magnitude of velocity, and displacement is the antiderivative. We can talk about total distance traveled. Total distance traveled is the area under the curve, and make that positive. So then that is negative of the antiderivative from 0 to 4, v of t dt, plus the antiderivative from 4 to 12 of v of t dt. So that's negative of 1/2 4 times negative 10, and then plus 1/2 8 times 20. So then I get the total distance traveled is 100 feet. Remember, this is the particle moving to the left and the particle moving to the right. So when the particle moves to the left, you have to make that antiderivative part negative so that the area under the curve remains positive. Okay, so let's go ahead and take a look at this next example. So this next example, we're going to find displacement and total distance traveled given the velocity equation. So to find the displacement is just equal to the antiderivative from 0 to 6 of your velocity equation, which is t squared plus 3t minus 10 dt. And so you take your antiderivative, so you get 1/3 t cubed plus 3/2 t squared minus 10t. And you're evaluating from 0 to 6. So you plug in all your 6's minus when you plug in all your 0's, and you should get 66. Now, when you go and look at your total distance travel takes into account when the particle is moving to the left that you have to make that a positive distance, not a negative distance. So we need to take our t squared plus 3t minus 10, set it equal to 0. We're going to try to figure out where the particle is moving to the left. So this is t plus 5 and t minus 2. So t is negative 5 and 2. So when we look at our interval, and I'm only going from 0 to 6, so interval, test value, v of t, and conclusion. I'm going from 0 to 2, and then from 2 to 6. And when I pick values, so I pick like t is equal to 1 and t is equal to 3, my velocity is then less than 0, and then my velocity is bigger than 0. So here my particle is moving left, and here my particle is moving right. So then my total distance traveled goes from 0 to 2, and we're going to make that negative of t squared plus 3t minus 10. And then we're going to add it to, going from 2 to 6, of my t squared plus 3t minus 10 dt. So what you will get here is you're going to go negative 1/3 t cubed minus 3/2 t squared plus 10, and you're going to go from 0 to 2, and then you're going to add it to 1/3 t cubed plus 3/2 t squared minus 10t, going from 2 to 6, and when you add both of those together, you should get 266 divided by 3. Okay, so now let's take a look at using our calculator. If we use our calculator for this function, we could do this by hand because it's a polynomial. But let's just say we want to use a calculator. Our displacement goes from, in this case, 1 to 4 of t cubed minus 6t squared plus 11t minus 6. And when you use your calculator, you're going to get 9/4. When I do my total distance traveled, I'm going to go from 1 to 4 again, but it's going to be absolute value t cubed minus 6t squared plus 11t minus 6 dt. And what you're going to get is 11/4. So now let's take a look at the calculator. So now when I look at my graphing calculator, I'm going to plug in, instead of t, I'll plug in x cubed, and then minus 6t squared, so minus 6 x squared, and plus 11t, so plus 11x, and then minus 6. Okay, so now second quit, go to my home screen, go math 9, and I'm going from 1 to 4 of my y1. So it's just like normal, go to vars, scroll to the right, function, enter y1, and I'm going to go dx, and I'm going to hit enter, and I get 2.25, which was my 9/4. And I'll do that again, math 9. I'm going to go from 1 to 4, but this time I'm going to put it in absolute value. Fastest way for me to define absolute value is to go catalog. There's other ways you could do it, but catalog right now, ABS, absolute value, is the first one. So then I go vars, scroll to the right, enter, enter, and then I go scroll to the right, go X. Oops, not B. Should be X. And then I hit enter. And that is my 11/4. Okay, so now let's take a look back. At another example, example 7. I given a of t is equal to -4. I want to find the total distance traveled. So I find v of t, which is -4t plus c. I'm given my initial velocity is 12. So that means that at v is 0 is 12, which means 12 is equal to -4 times 0 plus c, so c is 12. So v of t is equal to -4t plus 12. And then I want to figure out where the particle moves to the left, so I'm going to set this equal to 0. So t is equal to 3. So now I'm going to go interval, test value, sine of v of t, and conclusion. Zero to 3, and then 3 to 8, because that is my interval here. So I'm going to pick like t is equal to 1 and t is equal to 4. So my velocity is bigger than 0, and then my velocity is less than 0. So this is right and left. So that means that my total distance traveled is from 0 to 3 of -4t plus 12. And then minus from 3 to 8, -4t plus 12 dt. So then I would get -2t squared plus 12t, going from 0 to 3, minus, it should be equals, minus, or I could go plus 2t squared minus 12t, going from 3 to 8. And then what I should get when I take my antiderivative and then add them together, I should get 68. Okay? So now let's take a look at question 8. We could use a calculator to figure out where the particle is moving to the right, determine where the particle stops, and the total distance traveled. I could actually do this by hand if I really wanted to. So 0 is equal to 3 cosine 2t, and then you want to figure out where cosine of 2t is equal to 0, which you could use your calculator. You can graph cosine of 2t, set it equal to 0, and figure out your values. Or we can go back to advanced math, and we could say cosine is equal to 2t when, cosine is equal to 0 when my angle measurement is pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. You do the first two that happen between quadrants 1 through 4, and then you double it because the coefficient in front of the t is 2. You divide everybody by 2, so then you get t is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then you can do interval, test value, if you want to, without the calculator. Now, once I find my angle measurements, I could actually use the calculator, and I could figure out where my particle is moving to the right and to the left. So if we look at I'll graph it this time with Desmos, so we can flip back and forth real easily. Cosine of 2x, and it is being multiplied by 3. So remember, this is the velocity function. So that means that everywhere where it is above 0, so from here to up to here and back down to my pi over 4, so from negative pi over 4 to positive pi over 4, my particle is moving to the right. So that means from 0 to pi over 4, and then from 3 pi over 4 to 5 pi over 4, and then from 7 pi over 4 to 2 pi. My particle is actually moving to the right. So zero to pi over 4, union 3 pi over 4, to 5 pi over 4, union 5 pi over 4, to 7 pi over 4. Sorry, not 5 pi over 4. 7 pi over 4 to 2 pi. We already found out where the particle is at rest. Is when b of t is equal to 0, so that's t is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then the total distance traveled, we could use our graphing calculators from 0 to 2 pi, absolute value 3 cosine 2t dt. And if you do this with your graphing calculator, just like we did in the previous example, you should get 12. Remember that the absolute value is abbreviated ABS in your graphing calculator. Okay, so now what we're going to start to do is do separation of variables, where we group our y's on one side with dy, group our x's with our dx on the right hand side, and then we take the antiderivative of both sides. Okay. Okay, so let's go ahead and take a look at this example here. So we're going to go ahead and we're going to separate the variables. So that means that dy over y squared is equal to 4x cubed dx. And we're going to take the antiderivative of both sides. If you don't show the separation of variables, you won't get credit on a free response test. Okay, so now we're going to take the antiderivative. This is not ln on the left-hand side. This is y to the negative second power dy is equal to the antiderivative of 4x cubed dx. So this is negative y to the negative first power, and then it's x to the fourth plus c. So this is negative 1 over y is equal to x to the fourth plus c. And I'm going to go ahead and I'm going to use my initial conditions. So negative 1 over 1/2 is equal to 1 to the fourth plus c. So negative 2 is equal to 1 plus c. So positive 2. It should be a negative 1/2. So c is equal to 1. So then I get negative 1 over y is equal to x to the fourth plus 1. So the negative 1 is equal to y times x to the fourth plus 1. So y is equal to negative 1 divided by x to the fourth plus 1. So you must isolate y, which means y to the first power and a coefficient of 1. Okay, so let's take a look at example 10 here. Example 10, we're also going to separate the variables again. But there's no y involved. So this is just dy is equal to x sine of x squared and dx. Take the antiderivative of dy. So this is going to be a u substitution. So u is equal to x squared. So du is equal to 2x dx. So dx is equal to du over 2x. So this is y is equal to the antiderivative of x sine of u du over 2x. X's cancel out, so this is y is equal to the antiderivative of 1/2 sine of u du. Antiderivative of sine is negative cosine, so this is y is equal to negative 1/2 cosine of u plus c. So y is negative 1/2 cosine of x squared plus c, and then I'm going to solve for c, so I have negative 1 is equal to negative 1/2 cosine of 0 squared plus c. So negative 1 is equal to negative 1/2 times 1 plus c. So c is equal to negative 1/2. So then y is equal to negative 1/2 cosine of 2x and then minus 1/2. Okay. Example 11 is your second derivative. So when you take the antiderivative, and it's a little bit strange when you find the solution to this differential equation, but when I take this antiderivative, my dy dx is equal to x squared plus x plus c. You don't have to separate the variables for the second derivative. You just have to do it for the first. So I know that when x is equal to 0, y prime is equal to negative 1. So negative 1 is equal to 0 squared plus 0 plus c. So c is negative 1. So dy dx is equal to x squared plus x minus 1. And then I'm going to take the antiderivative of both sides by separating the variables. So dy is equal to x squared plus x minus 1 dx. Take the antiderivative of both sides. So y is 1/3 x cubed plus 1/2 x squared plus x plus c. So 3 is equal to 1/3 times 0 cubed plus 1/2 times 0 squared plus 0 plus c. So c is 3. So y is equal to 1/3 x cubed plus 1/2 x squared plus x plus c. Okay. Do another one here. So I'm just going to move the y by itself. So then dy over y is equal to 2x over x squared plus 1 dx. I take the antiderivative of both sides. So this is ln absolute value of y is equal to a u substitution. So u is equal to x squared plus 1 du is equal to 2x dx. So dx is du over 2x. Antiderivative 2x over u times du over 2x. The 2x's both cancel out. So then you're left with the ln absolute value of y is equal to the ln absolute value of u plus c. So ln absolute value of y is equal to ln absolute value of u. Your u is x squared plus 1 and then plus c. And this is just a general solution, so I have to leave the plus c involved. So the base of ln is e. So e to the ln absolute value of x squared plus 1 plus c is equal to the absolute value of y. So that gives me absolute value of y is equal to e to the c, e to the ln absolute value of x squared plus 1 by rules of exponents. So then absolute value of y is equal to e to the c times the absolute value of x squared plus 1. And then when I drop the the absolute value, it's going to give me with a plus or minus e to the c x squared plus 1 an absolute value. I'm sorry, not an absolute value. I could drop the absolute value on both sides. So I'm just left with x squared plus 1. Okay. Looking at the next example, write the equation for the curve that passes through the point and has a slope of this. So I want to separate the variables. So dy over y, sorry, dy times y is equal to x squared plus 1 over 2 dx. And you're going to take the antiderivative. So this is 1/2 y squared on the left. And then on the right, you have your 1/2. And then it is antiderivative of x squared is 1/3 x cubed. And then plus x. And then plus c. So 1/2 y squared is equal to 1/6 x cubed plus 1/2 x plus c. And then I can go ahead and plug in my point. So 1/2 times 4 squared is equal to 1/6 3 cubed plus 1/2 times 3 plus c. So this is 16 over 2 is equal to 27 over 6 plus 3/2 plus c. So then over 3, so 48 over 6 is equal to 27 over 6 plus 9 over 6 plus c. So 27 and 9 make 36 over 6, 48 over 6 plus c. So subtract, and I'm going to get 12 over 6 is equal to c, so c is equal to 2. So then my y squared is equal to 1/3 x cubed plus x plus 2. And then I'm going to take the square root of both sides. So y is equal to plus or minus the square root of 1/3 x cubed plus x plus 2. And based upon the initial condition, it is a positive result, so it is just the positive 1/3 x cubed plus x plus 2. The last one is, the last two deal with slope fields. So let's do the slope field here. So you're going to have an x, and you don't need to worry about your y values, plugging them in, because your slope field only has an x involved. So I have my -4, my -3, my -2, my -1 on the x. I'm picking all these coordinate points here and all the way up and down. -1, 0, 1, 2, 3, and 4. And I'm plugging them into my derivative. So I'm taking my x value and I'm multiplying it by 0.5. So I get -2, -3/2, -1, -1/2, 0, 1/2, 1, 3/2, and 2. So now my slope field are many tangent lines of these slopes that are down here. So my slopes look something like this, look something like this, and they're straight here, and then they start probably a little less steep, and then steeper, and then steeper, and then steeper, or the steepest, okay? Your next one does involve x and y. So x, y, dy, dx, and you have -2, 1, so that when you plug that into the derivative, you're going to get 2. -2, 2, you'll get 4. -2, 3, you'll get 6. -1, 1, you'll get 1. -1, 2, you'll get 2. -1, 3, you'll get 3. 0, 1, you're going to get 0. 0, 2, you'll get 0. 0, 3, you're going to also get 0. And I'm plugging this into my derivative, and I'm plugging in both my x and my y value. So 1, 1, you'll get negative 1. 1, 2, and you're going to get negative 2. 1, 3, you're going to get negative 3. 2, 1, you'll get negative 2. 2, 2, you'll get negative 4. 2, 3, you're going to get negative 6. And so then we're going to plot our graph, and we're going to look something like this. We'll get 0 across, downwards this way, more steep that way. And then for part B is to sketch a possible solution with this initial condition. So we look something like this. That's part B. And then part C is the separation of variables. So dy divided by y is equal to negative x dx. Take the antiderivative of both sides. So ln absolute value of y is equal to 1 half x squared plus c. Your initial condition is 0, 3, so ln of 3 is equal to negative 1 half times 0 squared plus c. So c is the ln of 3. So ln absolute value of y is equal to negative 1 half x squared plus the ln of 3. Base of ln is e, so e to the negative 1 half x plus ln of 3 is equal to the absolute value of y. And then e to the negative 1 half x times e to the ln of 3 is equal to the absolute value of y. E to the ln of the something is just the something. So 3 e to the negative 1 half of x is equal to the absolute value of y. To drop the absolute value of r's, this will always be positive. You need to make sure it's always positive, which it will be. So then y is equal to 3 e to the negative 1 half of x squared. And I say always positive because of my initial condition here. So my initial condition will result in a positive x value being plugged in and a positive y value, which would make this statement here always positive. And that is it for this lesson.